Hello everyone, myself Prasanakumar, Assistant Professor in the Department of Civil from VSB Engineering College, Tharu. Today I am discussing about the Unit 2 of Hydrology and Water Resource Engineering. In this Unit 2, we can give clear information about the runoff and what are the factors affecting during the time of runoff. In first topic, we see about the catchment. In general, what is meant by catchment? Catchment is the total land area where the rainwater collect and flows to the one common outlet. In other words, catchment is also defined as the drainage basin. It is an area of an land where there are water that falls as rain or snow collect and flow down into the single celled water body such as rivers or lake. We next see about the morphological characteristics of catchment area. First of all, it is defined as the environmental condition dictate how rainwater partition into the surface runoff versus groundwater. Again, it can be characterized by 5 different types as catchment area, shape, slope, drainage density, and land use and soil affect infiltration. Next we see about the catchment area. Catchment area defined as the total land area of collected water. Size dictate the volume of water could be sold. Larger catchment area should collect the more water, but it take longer for that all water to travel to the common outlet. Next we see about the shape of the catchment. The shape of the basin determine the how water quickly to reaches the extreme point when compared to the circular catchment as well as elongated catchment. In circular catchment, water reaches quickly, containing higher fed. When compared to the circular catchment, elongated catchment, the water reaches the solely at common exit outlet. Next we see about the slope. It is defined as the steepness is directly proportional to the water velocity. There are two different types of slopes should be presented, steep and flat slope. When compared to the steep slope, more runoff should be take place because the water flow from one point to another point is faster, and so more runoff to be calculated. In next we see about the drainage density. Drainage density, it is a measure the total length of the seam divided by the catchment area. There are two different types of density should be presented, high density and low density. In high density means more runoff should be estimated. When compared to the high density, low density produce more infiltration. Infiltration is nothing about it. How water can move downward to the surface of it. Next we see about the soil type. The physical and biological of soil determine the infiltration capacity. Sandy and loose soil which have large pores and storage of capacity of water should be large. When compared to the sandy soil, compacted and clay soil having very less amount of pores and so less infiltration should be take place. Next we see about a factor affecting runoff. Runoff is simply defined as the water from the rain or melting snow that cannot be absorbed by the ground and flow over the surface. Or it is defined as the runoff means rainwater that flows on the down surface and reaches the river's rate or reservoir instead of entering into the soil. Factor affecting runoff are rainfall intensity and duration, soil type and permeability, vegetation cover, catchment slope, temperature and evaporation, urbanization and land use. In next we see about the rainfall intensity and duration. Before that, what is mean the intensity and duration? Intensity defined as the how much rainfall occurs in shortest time with a specified time interval. Duration is defined as the how much rainfall occur in the length of the entire times. In easy understanding way, they are classified into rainfall into two different types: heavy rain and light rain. In heavy rain, soil cannot be absorb water quickly bit of more runoff should be take place when compared to the heavy rain. Light rain soil absorbs more water, less runoff should be take place. Next we see about a catchment area. Catchment area defined as the size of the land collecting for entire rainwater, or it is defined as the entire land is useful for to collect the rainwater. There are two different types of catchment area should be identified. Big area and small area. In bigger area, large amount of water should be sold as well as more runoff should be take place when compared to the bigger area. In smaller area, small amount of water should be sold as well as less runoff should be take place. Next we see about the soil type or soil characteristic. It is soil is a main source responsible for infiltration capacity. There are two different soil types should be presented: sandy soil and clay soil. In sandy soil, it contains large number of pores. By using this pores, water can enter quickly and less runoff could be take place. When compared to the sandy soil, clay soil having small pores, and with the help of the small pores, water enters slowly and more runoff could be estimated. Next we see about the infiltration capacity. Infiltration capacity defined as the maximum rate at which the soil can absorb water at any given time. For an example, there are two different types of infiltration rates should be at high infiltration rate and low infiltration rate. In high infiltration rate, less runoff should be estimated. In low infiltration rate, more runoff should be estimated. Next we see about temperature and evaporation. During the time of the high temperature, water evaporate more as well as less runoff should be calculated. At the time of the low temperature, less evaporation should be take place as well as more runoff should be calculated. Next we see about the runoff estimation using change table. Change table is widely used in empirical tool of hydrology to estimate the volume of water that will flow from a catchment area into reservoir or pond in a given specific amount of rainfall. It is a primary used for small to moderate water seed to design a irrigation and storage structures. It gives runoff percentage based on rainfall amount and catchment conditions. Next we see about a basic principle. In this basic principle, different catchment produce a different runoff. Yet in the catchment can be classified into three different types. They are good catchment, average catchment, bad catchment. In good catchment, they are considered as forest area because in the forest area, more infiltration rates should be take place as well as automatically less runoff should be estimated. In average catchment area, vegetation landing should be considered. In vegetation area, medium runoff as well as less infiltration take place. When compared to the duct and the average catchment, bad catchment produce and less infiltration rate as well as less amount of runoff should be estimated. We next see about what are the procedures should be followed. There are five different steps to follow to calculate the runoff. In first step, we find out the total amount of rainfall in given particular location. After that, we can identify the catchment condition. For an example, there are three different catchment conditions should be take place: good catchment, average catchment, bad catchment. After we find out the catchment condition, we can use the change table. After that, we can read the runoff percentage with the help of rainfall as well as catchment area. Finally, we will calculate the runoff by using runoff percentage multiplied by rainfall divided by 100. Next we see about the runoff estimation by using empirical method. Empirical method means the estimating runoff using formula developed from the observed field data and experiment, or it is defined as the runoff estimation or simplest formula based on the past observation rather than a complex species. They help engineers quickly estimate how much rainwater will flow across the specific area or specific location. This formula are created based on the rainfall data, catchment area, soil condition, and regional climate. There are four different types of steps should be followed. In first step, we can measure the rainfall at particular location or area. Then after that, we can select a suitable temperature formula for particular site. Next, we can substitute the value. Finally, we can calculate a runoff by using Q is equal to CIA, where Q is a peak discharge in meter cube per second, where C is a runoff coefficient, a number between 0 to 1 that represented depend upon the surface area, where I is a rainfall intensity and A is the surface area of given surface. Next we see about the SCSCN method. And SCSCN means Soil Conservation Service and Term Number. It is a method widely used and simple mathematical formula used to estimate the how much rainwater turns into the surface runoff versus how much soaks into the ground. The entire method tells about an easy to understand the value called as curve number Cn, which represent the runoff potential of a specific area. There are five different steps could be followed to calculate the SCACN number. It includes, first of all, we find out the total amount of rainfall in a particular area or location. After that, we identify the land use and what type of soil should be used in a particular location. Yeah, after that, we can select the proper curve number. Again, we can calculate the storage of entire area. Finally, we can calculate the runoff value. Next, we see about a sage-discharge relationship. Sage-discharge relationship is often called as rating curve. It is a simply mathematical capital link between the how high water and how much water is flowing at a specific point in a river. Mainly, the discharge can be calculated with the help of Q is equal to AB, where Q is a discharge, A is a area, and V is an velocities. Next, we see about a flow measurement. Flow measurement, it is a process of calculating how much liquid move to a pipe or channel. The main purpose of this measurement are to measure the river discharge. There are two different types of methods should be used: velocity area method and flow method. In velocity method, we can directly estimate the flow measurement by using Q equal to AV, where Q is an discharge, A is a cross-sectional area, where V is a velocity. Next we see about the hydrograph. Hydrograph is defined as a simply graph that shows how the water flow in a river changes over time. Or otherwise it is defined as a graph between the discharge and the time taken. Next see about what are the main parts of hydrograph. There are four different parts as rising rim, peak flow, falling limb and base flow. In the rising rim, it is a upward sloping curve on the graph that shows the rivers flow rapidly increasing as rainwater run off the land and into the river. Next we see about a peak flow. It is the highest point of the hydrograph, maximum discharge during the time of rainfall. Next we see about a falling limb. Falling limb, it is a downward curve, shows the rivers flow gradually returning to the normal baseline after the rain has stopped. Next we see about a unit hydrograph. Unit hydrograph is a simple and practical tool used in hydrology, used to predict how much water in a river will carry as an outlet after a specific amount of rainfall. Or it is a defined as the hydrograph produced by 1 centimeter of effective rainfall occurring uniformly over the catchment for a specific duration. Next we see about what are the assumptions to be followed in unit hydrograph. Rainfall is uniform, duration is constant, linear response, catchment characteristic remain same. Rainfall is uniform means during the entire calculation, rainfall falls equally over the particular location. Duration is constant means that rainfall occur during the fixed time interval. Linear response means more rainfall is directly proportional to the increase in the amount of rainfall. Next we see about what are the steps to should be followed, develop the unit hydrograph data and follow the four different types of steps. In first we can find out the total amount of rainfall or measure the rainfall in a particular location. After that we can find or calculate the effective rainfall. After that we can measure the runoff hydrograph. Then it can be converted into 1 centimeter rainfall basis. After finally we can obtain the unit hydrograph. At the end of this unit, students are able to gain knowledge about how rainfall is converted into runoff and reaches the rivers or reservoir. And also students are able to gain knowledge about what are the methods that used to estimate the runoff.